Okay, so for Bernoulli trials, we have these things called combinations. This is the button we'll use in our calculator. It says N with a capital C and a small r. You'll see it above the division symbol of this calculator here. This is the formula that we are given in the book and in the logbook on page 33. I actually don't use this formula too much, and to be honest, even looking at it now, I know how to use it, but I forget, so I actually use a different method to try and understand this. But I'll explain why as I go along. I'm not trying to make it more difficult, and if you are okay with these Bernoulli trials and the type of questions I'm doing, then don't do it my way, keep using the formula. But if you struggle understanding what the question's asking you, that's why I teach it a different way, because in my experience, the way I teach it, I think works for more people in general. But of course, these things don't work for everyone. So for Bernoulli trials, what are they? Well, I think the giveaway for Bernoulli trials is there's only two outcomes. So that's like a win or a loss, getting a heads or tails, a score or a miss in a game. The odds won't change, so sometimes they might give you different type of odds where you have to draw. If the odds change in general, you should be drawing those tree diagrams, okay? But the odds won't change, so your probability of a win and your probability of loss are constant throughout the whole game or whatever you're doing. And the trials should be independent, so again, that's just similar to the odds don't change, they don't affect one another. I'll use this thing called the box method, all right? So I'm sure other teachers use this as well, but it takes a tiny bit longer to do, but it's easier, I think, to understand. And I just think in general these questions are confusing, maybe. So here's a typical type of question. You might see that it's a Bernoulli trial. So the probability, it says, of Felix scoring a penalty is 70%. Work out the following if he takes 5 penalties. So first thing is we want to write down the probability of scoring. So that's usually written like this, P brackets the probability of what happening while scoring. 70%, of course, we don't use 70%, we use 0.7. And since it's a Bernoulli trial, there are only two outcomes. You may remember all the outcomes are up to 100%. So therefore, if he's a 70% chance of scoring, he must have a 30% chance of missing. So now, he scores 3 out of 5 penalties. What's the odds of that? So let's draw out the 5 boxes first and let's see what that looks like, okay? So here are my 5 boxes, okay, for the 5 events that are happening. So for me, what I always ask my students to do first is to write out a successful scenario, say, or how that would make sense to achieve scoring 3 out of 5, right? So a successful scenario can be anything as long as there's 3 scores and obviously 2 misses. So for us, I might go like this. I might say, well, let's just go simple enough that he scores the first 3. So he goes score, 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 and then he has two misses, yeah? So let's write in the probabilities for each of these. So for each of the scores, it's a 0.7 of probability. And then for each of the misses, it's 0.3. So what we actually have is we have 3 0.7s and 2 0.3s. Now, we multiply these numbers. If you're unsure why we do that, well, in general, when we say the word and, we multiply. When we say the word or, we add. We can do that in another video. That's kind of junior cert probability, but I'll explain it here. So he has to score the first one and the second one and the third one and miss the fourth one and miss the fifth one. So we've these 3 numbers multiplied. It doesn't matter what order you multiply things in. So even if we had separated those with score, miss, and score, it still would have essentially the same numbers multiplying. So let's write it down this way. 0.7 multiplied by itself 3 times is to the power of 3. That's why you might see it written like that. And the 2 misses at 0.3. And there's 2 of those, so that's going to be to the power of 2. Now, this NCR stuff, why do we have that? Well, we could actually think of all the scenarios that can actually happen here. And we can work out all the probabilities. They're always going to be this. But how do we know we hit every one? Well, we can keep guessing and just hope we hit every one. And essentially, you can do it that way, or your other way, or your other way. And when we keep saying or, we essentially are getting this probability all the time. We will add all the options that we get because he can do it that way, or that way, or that way. But it's very hard to think about that and write out that sample space, you might call it, in your head. But that's where the combinations button comes in. So we have these 3 scores to rearrange within 5 boxes. So we have 3 things to rearrange in the 5 boxes. So we have 5 boxes, choose 3 things to rearrange, or 5 choose 3. Okay, if I do that in my calculator, I get 10. So I'm going to multiply that. I could write down 10 here, but just for the sake of explanation, I'll write down 5 choose 3. Now, just so as you're aware, that can also be written by these long brackets with a 5 and a 3 down here. It's not a fraction, It's just another way of writing that choose notation. You may be familiar with it from the binomial distribution formula or theorem. So we're going to write it this way: 5 choose 3. So we've 3 things to rearrange in the 5 boxes. And this will tell us how many ways that can be done. It's also worth noting that 5 choose 3 is actually the same as 5 choose 2, because rearranging these 3 scores is the same as rearranging these 2 misses. So just, if I show you, I got 5 choose 3 is equal to 10. If I did 5 choose 2, I would actually also get 10. So just, that might be something you heard of in class already. So if I do all this there, so I have 10 here, multiplied by 0.7 to the power of 3, and multiplied by, multiplied by a further 0.3 to the power of 2. If I do all that, I get this 3087, and I'll write it down here, over, looks to be 10,000. And of course I can do that as a percentage if I want. In general, never go to decimal unless you're asked, but let's do it here anyway. So this is a nice decimal, 0.3087. So it's like almost 31% chance of that happening, okay? We're going to stick with these probabilities for the next 3 questions. So remember, the probability of score is 0.7, the probability of miss is... So now we have this one, like he scores at least once. So you'll actually see this quite a bit. It's kind of a unique little question, and you may have heard your teacher correctly say, if you see the word at least, it's kind of a 1 minus the probability type question, but I'll explain that why. So if he scores at least once, you're talking about him having a scenario where he scores once in the 5 penalties, that's a success. He scores twice in the 5 penalty, that's a success. Scoring 3 times, scoring 4 times, scoring 5 times. The only thing that doesn't work here is if he misses all the penalties. So let's think about what a miss would look like for all the penalties. So he's to miss all 5, so actually I'll just put them in. So that's 5 misses. So we have 0.3 for the first miss, and all 0.3s, and 0.3 for the last miss. That's 5 0.3s. And if we do that in our calculator, we get 0.5 to the power of 5 gives us, 0.3 to the power of 5, and that gives us 243 over 100,000, it looks like here. Okay, so that's a fairly low probability that he'll miss them all. Obviously, he's such a good penalty taker, so they think he's going to get once, but that's the only probability that doesn't work for us. So if that's the only probability that doesn't work for us, all the other probabilities, remember, and this one add up to 1. So if we say 1 minus that guy there, 243 over 100,000, let's see what we get. So I'll just do 1 minus the last answer that I got, and I get 0.99757. So it turns out that he has like a 99.8, I suppose you rounded up, % chance of scoring at least once if he takes 5 penalties. So I hope you understand that one. Now, back to more standard, I think, Bernoulli trial questions. Here's one that you see quite a bit, isn't it, in the Leaving Cert, I think. He scores for the first time on the 3rd penalty. Okay, so let's draw out the first 3 penalties, and let's think about how this will look. So if he scores for the first time on the 3rd penalty, that means this guy here has to be a score, and it means these 2 have to be a miss. So these have to be a 0.3 and a 0.3, and this has to be a 0.7. There's actually no combination button again to do here. We just have to go miss and score. And since I'm saying and, it's these 3 numbers multiplied together. And that gives us 63 over 1,000, or 0.063. So the chance of that happening is, that's decimal, is like a 6.3% chance of happening. Okay? Now, the last one, I think this is the key question to understand, I think, from this. He scores for the 3rd time on the last penalty. This is the one you have to tune into if you're doing higher level maths, I think, here. So, let's draw out the 5 boxes. That was a bit big. 3, 4, 5. Okay. If he scores for the 3rd time on his last penalty, that means his last penalty has to be a score. Now, this guy is locked in place. He has to be a score there if he scores for and the last one has to be his 3rd. Now let's go back to the first page and let's think about this successful scenario here. And let's think of what one looks like here. If he scores for the 3rd time here, let's say he scored in the first 2 times and then he went miss. This one is true for what we need. So it's 2 scores, 0.7, 0.7. It's 2 misses, 0.3, 0.3, and it's a score at the end, okay? We can work out this scenario and see how many ways we can rearrange it. Because essentially, all I need to rearrange are these two scores within these four boxes and these two misses. And always, I will not be touching this score at the end. I'll just be rearranging these two scores or these two misses, either one. So let's work out what we have here first in 0.7s and 0.3s. We have 0.7 to the power of 3 for the 1, 2, 3 of them. And we have 0.3 to the power of 2. But how many combinations we get, that's when we forget about this guy over here and see how many ways we can rearrange these. So again, we're rearranging two scores within four boxes. That's going to be 4, choose 2. And if we do that on our calculator, we're going to get 0.7 to the power of 3, 0.7 cubed, and then a 0.3 squared times 4, choose 2, and that will give us 9261 over 50,000, it looks like. And if we do that to decimal, 0.18522, or approximately 18.5% chance that will happen. I hope that makes sense for the Bernoulli trials. I don't like using the formula. I prefer using the boxes, especially when it comes to a scenario like this. I think it makes more sense.